and those of the last 3 weeks were routed by strong winds. Research has also shown that 65% of the building collapses occur during the rainy season. Today on the Nigeria Property Show, we will be talking about the need to build right with regular maintenance to prevent building collapses. If you're just joining us, it's the experts on the Nigeria Property Show. Today on the experts, we have with us architect Akinola George. Architect George is also a fellow of the Nigerian Institute of Architects and the president of the Building Collapse Prevention Guild. The Building Collapse Prevention Guild is a group of professionals in the built environment working with government and partnering with the public to ensure a thorough knowledge of what to do to build right towards preventing collapses. Tell us what should we know when we say we're building right? The collapses witnessed in the past came on during the rains, during the rainy season, and that's what has informed the topic we're treating on the experts on today's program. We're looking at building right towards preventing collapses. What should we do? What should the public know about building right?
You know, the process of procuring a building. So you meet with the surveyor. The surveyor, you know, gets you your survey document. That introduces the first step. The second step is you go to, if it's a very small property, you go to your architect. If it's a large, maybe you want to develop a town or something, you go to your town planner, or you know, an estate, you go to a town planner to put, you know, the layout right. The architect now puts the design together for you as it should be. You know, it takes care of the environment, takes care of the topography, takes care of your needs, your comfort indices, and a lot of things that you need to put together to make that building right for you. It's like, in a way, when you want to buy a dress, you take it to a tailor to put together for you. But the architect is properly trained in being able to put that building together for you. Next. The design, you mean? The design, yes. Next, the structural drawings are done to take, like, the skeleton of the human being. You know, the engineering of the human system cannot stand without the skeleton. So you need the reinforcement details of the concrete structures and the concrete mixes and whatever to put that design together so that it can stand. Okay. Then a builder builds. And from there, of course, you know, the quantity surveyor will put the cost together. Then your building is right for the market, and the estate value is right for the market. Yes. You said the quantity surveyor will put the cost together. The cost of building materials and all of what will go into the building. Then the builder builds, and you know, once the building is finally prepared, it's ready for the market, where the estate valuer puts it on the market. Where does the soil test come in? Oh, it comes in. What's the significance of the soil test in building right? Okay, there's a particular branch of engineering called geotechnical engineering. Geotechnical engineering is where they, you know, go into the soil to determine whether that soil type what kind of foundation can we use in that soil to be able to know the bearing capacity of the soil, such that when we put that building there, it will not fail. So it will guide the engineer to know the kind of reinforcement to put in place.
What does that soil test got to do with the lifespan of that building to prevent a collapse in future?
Well, there are different kinds of soils. You know, you have the loamy soil, the clay soil, and so on and so forth. So the geotechnical engineer examines the soil. There are a couple of equipments that they use. They examine the soil to determine what kind of foundations will be right for that place. This, the structural engineer uses to prepare his calculations and determine the amount of reinforcements, the quality of the reinforcement, the various sizes, the constituency of the concrete that he has to put in place together to form the reinforced concrete. Okay. And the blocks where the infill panels will be, where the load-bearing beams or columns will be. So that is the work of the geotechnical engineer, advisory to the structural engineer. You've taken us through the stages of getting the building, getting the building on ground. How about maintenance? What has maintenance got to do with preventing building collapses? Well, we hear that every building has its own lifespan. Definitely. There's none that doesn't have an expiry date. Even human beings, we have an expiry date. But you can keep your dates from, you can keep yourself from expiring early if you maintain properly. So you can keep that building from expiring if you maintain the building properly. Basically, once every 6 months you paint your building. That's maintenance. So cobwebs will not stand, ants, molds, and whatever will not grow. Grasses that are today grasses can end up becoming trees in 5-10 years if you don't cut the grasses. So, and the roots of big trees can end up, uprooting your foundation. So you have to maintain the environment. You have to maintain the building. Once in a while, check your roof. Make sure that your roof has cavities. Cavities that will be able to, that will not allow pressure to build. Because if pressure builds... What does that mean, cavities in the roof? Okay. When you put a roof together on a house, you have to allow air to escape. So you create openings for the air to escape. Otherwise, when there is turbulence, high wind, the tendency is for the pressure to build inside that roof. If, before you know what is happening, that roof has lifted off. That's what causes all these roofs to shift. Because there is no escape for the air coming in. The air coming in must not be allowed to build pressure. Otherwise, it will take the roof off. So you have to create openings. This we do scientifically. They're properly placed in a way that they will not allow reptiles to creep in. But all the same, you have to put this in place so that the roof does not lift up. So regularly, every once in a while, you check your roof, go into your roof and see that the trusses, the wooden trusses that you use to put up your roof, that they have not rotted, they are not caving in, they are not bending. Then you check your roof itself, the roofing element. Maybe you use a corrugated iron sheet, or you are using asbestos, or you are using long span aluminum, that some of them are not leaking. What other things are the major points of maintenance? Quite a number. For a building. Could you outline some of them? Okay, let's take the building itself. In some places, you discover that soils begin to shift away from buildings. They begin to shift away from foundations, thereby exposing the foundation. Oh. And there is this thing you see around termites. Termites can bring down a building. How can that be? Termites? Yeah. Insects? Insects. Over time, they continue to eat at a particular vulnerable part of a structure. Okay. Before you know what is happening, the soil begins to shift from under that structure and cracks begin to appear. If you give it time, the building comes down. Ants can go into your roof where the place is not, where the the timber trusses are not properly coated for anti-termites. Okay. They will eat the roofing structure, they will eat the elements, and before you know what is happening, the roof comes down. So all these are maintenance details. Any architect that has finished the house should submit, along with his designs, a maintenance manual. Okay. So this maintenance manual should is designed to guide the owner of the house over time, so that the house will be kept in a proper state of wellness before it expires.
A proper state of wellness. Now you're looking at an architect finishes the proper job and also hands over a maintenance manual.
Yeah.
Things for the owner of the building or the manager of the building to look at once in a while and say, before the rains, I should do this. What should we do before the rains to keep the house in top shape?
Well, we assume that from the beginning you've patronized the right professional. So if you patronize the right professional, your building is expected to withstand the rains. Number one, the rain comes in different forms. You have the normal rain that falls vertically, or maybe approximately vertically. You have some that fall at angle 45 or more, depending on the wind speed. Then you have the ones that create turbulence, the ones that follow, the windy storms, high winds, thunderstorms, and all kinds of rainfall patterns require different kinds of treatment. The normal driving rain, that is coming, at an angle may enter your building if your window is not properly done. So your window has to have a window hood that takes into consideration the angle of the rainfall and the wind speed, such that, the rain as it's coming in is covered by the rain hood, doesn't enter the house. Once it enters the house, it starts degenerating your structures. Rain in the building can soak into structures and, reinforcement begin to rust. So that is one area that you have to make sure you take care of. As I said earlier, make sure that you create escapes in your roof for the roof not to lift off. Because if wind comes into your building, it builds pressure inside your roof. And the tendency is for the roof to lift off. So most of these roofs that you've seen, like Moremi Hall Unilag, I had the roof got lifted off and landed somewhere in the school, it's as a result of something like that. So if the roofing structure is weak, the building will, the roof will cave in if there is heavy wind. So as the rains are coming now, make sure that your compound, if you see loose holes everywhere, make sure you seal, with maintenance concrete. Okay, so the rain does not seep in.
Provision of housing is at the core of every government's goal. But in doing this, there is an urgent need for a paradigm shift, as done in developed countries, moving towards smart buildings for sustainable development, while pursuing safety for the environment. Since cities are the future of the urban-built environment, with the increasing population demanding more functionality, then the need for smart buildings is long overdue in Nigeria.
Nigeria can do that by investing in alternative construction methods and in renewable energy alternatives for powering smart buildings, because it's all hinged on having a smart building is all hinged on having electricity. For the construction process, for the project development, and for maintenance, you need power. And so having a smart building is all hinged on the power, having a good power sector. So if we can invest in renewable energy alternatives, where buildings are powered on their own, the heat, ventilation and air conditioning systems and lift systems are powered by alternative energy solutions, then we can move towards having sustainable smart buildings and smart cities.
A century ago, residential and commercial buildings were just concrete and brick with spaces for electricity and water. But reducing energy consumption, compliance building regulations, and climate-resilient constructions are the drivers of modern buildings, not just for comfort, but smart metering, smart sensors, intelligent building materials for high-performance buildings.
As it is, all land in Cairo belongs to government. And the minimum floor you can go in Cairo is 4 floors. That means with 4 floors, you will accommodate more people. And if you see the way they construct, it's very, very cheap. they do frame structures, and the red brick that we have abandoned. That is the mode of construction in Cairo now. It's cheaper to construct, and people will just move in. You will accommodate a minimum of 8 families. So once we have the idea of me building my own house, you building your own house, we must live together. And that's what is making the land more expensive. But once the government owns the land must be made available for whoever that wants to develop. If it's not for your own personal use, we must discourage individuals building their own house.
Smart buildings could be referred to as automated buildings that achieve significant energy savings to reduce greenhouse gas emissions through the use of improved technologies, climate-smart adaptive materials and structure, electrical systems, and a most sensitive part of constructions, smart plumbing. Methods to achieving gradual but steady progress includes increased knowledge among the public and continuous research with professionals.
NIBRI has been working a lot on producing of alternative building materials or skill acquisition in different areas. There are constituency projects that they use skill acquisition. There are this mobile housing. There is a bit to bring to the general public the idea of using NIBRI technology to produce mass housing. And there are a lot of other places, like if you get to Jos, if you get to Newi, if you get to Gombe and Kano states, even in Lagos here, we have a prototype house at Yaba, which NIBRI has produced, and to show that with this, NIBRI can mass produce with its technology to have a lot of houses in the country.
As construction professionals, we should be looking at integrating new, well-researched components into the building process to drive the demand, to drive the patronage of smart buildings, because it's also a cost component to managing smart buildings. Yes.
Benefits of smart buildings is all-encompassing to occupants, the society, and the environment at large, with a central sewage system, controlled waste management, and minimal energy consumption source towards sustainable development. We have heard that every building has a lifespan and must be protected and maintained for optimum use. I hope you found today's show informative. Join us for a fresh edition next week. I am Remi Oladende. Bye for now.